Yourself Energy Audits webinar. I am Mary Benson from the Ameren, Illinois Act on Energy program, and I'm here with Donald Fournier, who is the Managing Director of the Smart Energy Design Assistance Center of the University of Illinois. Today, Don's going to be talking about how to conduct energy audits at your business facility. Now, before we get started, I'm going to cover a couple of quick housekeeping items. I wanted to let you know that I do have the participants muted so that we won't pick up on any background noise. And wanted to let you know that this event is being recorded, but as you can see, the participant names are hidden so no one else can see who's logged on. This recorded online training event and the handouts from this session will be available on the Act on Energy website on the Education and Training page. And I'll also be sending you an email with links to the handout and the recorded webinar so that you can access this information. You don't have to take a lot of notes, and any links that you see during the presentation will be included. Any URLs will be included in the handouts, so any websites that we reference. Also wanted to let you know that if you do have any questions during the presentation, to please type them in the chat feature. I have a picture of what that looks like on the screen here, and that's located on the bottom right side of your screen. So anytime throughout the presentation that you have any questions, please feel free to type those into chat and we will get those answered for you. Also wanted to let you know that after this session, I'm going to be sending you a survey, and so please provide me with your feedback, and this session is going to last about 60 minutes. Now, what I'm going to do next is I'm going to ask you 3 questions to find out what you already know about energy audits, and then once you've chosen your answers, if you could please hit the submit button. And you'll have about a minute, so I'm going to open the poll now, and you'll have about a minute to submit your responses. Okay, it looks like most of you have submitted your responses, so I'm going to give you just a few more seconds here to finish up for the rest of you. And I'm going to close down the poll in 5, 4, 3, 2, 1. Closing the poll. And I want to let you know that I will be you'll be taking the same quiz at the end of the presentation, so I'm not going to share the correct responses now, but I will share the poll results so you can see what everyone else responded. And then we can compare the results at the end, and I'll give you the answers at that time. So here I'm sharing the results, and it looks like most people answered C for number 1, A for number 2, and B for number 3. It was a close call between B and C. So once again, I'll go over those correct answers at the end of the presentation. Now I'd like to know, what would you like to get out of today's online training event? If you could please type your responses into chat and let us know what you plan on getting and what you would like to get out of today's presentation. Okay, some people are saying how to help our customers reduce costs at our facility, how to perform energy audits and identify improvements. We'll definitely be covering that. To find ways to save energy at the plant where I work. Great. New to this process, and so the experiences in cost avoidance, identify significant energy wasters, to find out when you can ask for customer compensation for an energy audit, to reduce costs, some simple measures I can use to improve efficiency, ways to identify energy savings. We're definitely going to cover these things. Some specifics of what contractors look for when doing energy audits, and how to be more equipped in discussing the benefits to customers, and to know more about the field and what to do, and reduce energy costs. So great, thank you very much for submitting those responses. We're definitely going to cover those items, so thank you very much. Now I'm going to introduce Donald Fournier, and he is the chair and a senior researcher at the School of Architecture's Building Research Council. He is also the managing director of the Smart Energy Design Assistance Center, also known as CDAC. And CDAC has conducted over 800 building energy assessments in the past 7 years and provides advice and support on the Illinois Energy Office. So without any further ado, I'm going to introduce Don Fournier, and I'm very interested in hearing about and learning from Donald today. Welcome, Donald.
Hey, thank you, Mary. Hope everybody can hear me all right. What I'd like to do today is to go over several aspects of looking at a building. And I feel like when you start doing an energy audit or an energy assessment, you're really taking a different look at your building. Many people get their bills, they really care just about the cost, they're not looking at the therms of the kilowatt hours associated with it. So we're going to look at our bills a little differently today. So the idea is that you can learn where your energy dollars are going, where your big expenses are energy-wise, learn how to rank your building against other buildings, to see where you stand. Are you an efficient building, or are you an energy-wasting building? And then we'll talk a little bit about some of the low-cost, no-cost things you can do, and other ways of looking at larger investments in your building. And learn how to present your ideas on energy saving in an effective manner so that you can convince the people to spend money on that building. That's a big imperative. To present your ideas in a coherent manner that makes sense from a business case. So some definitions, we probably ought to talk about some terminology. An energy audit, or we call it sometimes an energy assessment, is a systematic review of your building's energy usage and the opportunities to reduce it. And we talk about energy cost reduction measures, ECRMs. There are other labels out there. You may hear ECM, energy conservation measure, ECO, energy conservation opportunity, but we feel there's a difference between conservation and efficiency, and they both lead to reducing costs, so we like to talk about energy cost reduction rather than energy conservation. And so when you look at a building, you're going to be developing something we call an energy cost index, looking at how much your energy costs are per square foot of the building. Also an energy use index, which talks about how much energy you use per square foot of the building, and we convert both the electrical consumption and natural gas consumption, if you have it, to 1,000 BTUs per square foot. And it's a way you can index that building and rank it. Bearing in mind, a KBTU is 1,000 BTUs, a kilowatt hour is 1,000 watt hours. We also might talk about lighting power density. This is how many watts your lighting system uses per square foot of space that you have. And it's a way of looking at lighting and ranking how efficient it is. And of course, HVAC stands for energy, ventilating, and air conditioning. So these terms come out and get thrown around. I'm going to base most of this talk on something called Procedures for Commercial Building Energy Audits. It was recently published by ASHRAE. ASHRAE is the American Society of Heating, Refrigeration, and Air Conditioning Engineers, and they tend to be the sort of the thought leader in the nation on buildings and energy use in buildings. So they define sort of 4 levels of an energy audit or way to look at a building. What they call preliminary end-use analysis, and we'll go through this to discuss how you calculate the kBTUs per square foot, how you compare your building to other ones of a similar type and use. And then there's a level 1, 2, and 3. Level 1 is a walkthrough, and then looking at where the energy is going, looking at the devices in the building, looking at energy uses in the building, and identifying some project. Level 2 is a more in-depth survey and analysis. Tries to break down where the energy is going in a building. There's a detailed analysis of the energy-saving opportunities in the building, both developing the costs and the savings for those ECRMs. And you may be looking at some operation and maintenance changes in the building that could save some energy. And then level 3 is a very detailed survey and analysis, or what they call an investment grade audit. And you typically do a simulation in a computer code of the building, and you look at all the measures that are available. Today we'll get into the preliminary analysis, the walkthrough, and some of level 2. And level 3 would be beyond our scope, and much of level 2 and 3 really takes a professional in the field to perform those duties. So, gathering your pre-visit site information. First, you want to identify in the building who the key stakeholders are, whether that's the owner or the operator of the building. Get the information on them, how to contact them. You probably want a meeting with these folks before you really get started, and you certainly want to present your findings to them. And find out what their concerns are. Are there issues with the building? Do they have cold problems or heat, too hot spaces? You know, what do they want to get out of it? Or do they want to do major modifications or just do low cost, no cost things? So from them, you get a feel for, you know, how vested they are in saving energy in that building. And then you want to ascertain, basically, what's the function of the building. Pretty straightforward, but and the other thing you may want to find out is, has the building changed use over its life? And that's fairly common in a lot of buildings. So it was built as a school and now it's apartments or something like that. You know, you need to know what the building was originally designed for and whether they're using it today. Certainly the size of the building, and you'd like to get about 2 years of utility bills, all the energy bills, and then some climate data, basically heating degree days and cooling degree days for those 2 years. So you can match these together and look at the building over time. If available, certainly a floor plan and construction documents. And if they've had any previous audits, you'd like to gather that information. And if it has process loads in the building, certainly gather information on the equipment that is in the building. Okay, then you schedule your visit, excuse me, and then you like to visit the building and go through it. If you do it yourself, maybe you're very familiar with the building and you know what's in it and where things are. There's a larger building, you may have technicians that are working in the building, and certainly get with them. They're very familiar with the systems in the building. They can help you. They can discuss what their issues and problems have been. So all of these can come together. So somebody who's very familiar with the building needs to be part of that walkthrough process. So when you do the preliminary analysis, you're going to analyze the historical utility data. You're going to gain insight to the building by looking at this data. You're going to look at its current operation, its trends, what's the schedule of the building? Is it open, 10 hours a day, 12 hours a day, 24-hour a day operation? You're going to get a feel for some of the energy end uses in that building, and then you're going to look at its overall performance. And we'll talk about how to get this in a second. And then you're going to review the consumption versus climate. By this, and I'll show you that you're going to plot each month the energy consumption, if it's electrical versus cooling degree days, if it's thermal, say gas, versus heating degree days. And there's a URL there where you can get the data from the U.S. government. You just pick the location closest to you is the best you can do. And we're going to benchmark the building. We're going to determine how this building operates compared to similar buildings in the same climate zone. Same type, same size, and we're going to determine a target for energy efficiency from that. You're going to look at how well your building performs and get an idea of how much improvement may be available within that building. So to get started, we need to really think about there are two types of buildings before we start looking at the bills. One is what we call envelope dominated, and its energy pattern is tied pretty much to climate. So when you plot energy consumption versus heating degrees or cooling degrees, you're going to see a very definite pattern there. And it's going to be based on weather. And typically, buildings below probably 50,000 square feet tend to be envelope dominated, but that's not a general hard cast rule. I looked at the Pentagon, which is a very large millions of square foot office building in Washington, D.C., and it was envelope dominated. So, you know, size isn't a full determinant. And then the other type of building is internal gain dominated. And its energy pattern is either not connected at all to climate or loosely connected, and it may have a cooling demand year-round. Large buildings with big interior zones, those may be cooling zones year-round. Or there's a lot of equipment or process going on that tends to overcome the envelope aspects of the building. So you need to get a feel for that, and you can pretty much tell this by the bills when you analyze them.
Okay, now I have a question for you. I'm going to open this poll, and if you could please let us know, is your business housed in an envelope-dominated or an internal gain-dominated building? And I have the definitions there to remind you. You could submit your responses. Okay, looks like almost everyone has responded. So far, envelope dominated is winning out by a lot. So I'm going to get ready to close the poll here. In 3, 2, 1, closing the poll, and then I'm going to share the responses and let you see what everyone else responded. It looks like A wins out by a lot. We've got 55%. Well, 31 of the 56 people who responded said envelope dominated, and 6 of the 56 said internal gain dominated. So thank you very much for submitting those responses and for participating. And so now I'm going to hand this back over to Don.
Okay, thank you. Well, this is a sample of a building we looked at. It happens to be located in Champaign, and we took the energy data monthly, took the cooling degree days, and this is the electrical consumption, and plotted it out month by month. And you can see that the degree days are the line, and then the bars are the kilowatt hours. And you can see that this seems to be an envelope-dominated building, but at the same time, it seems to have a very large base load of electrical consumption. This is essentially an office-type facility, and you would think that the cooling peak would be a more dominant part of the electrical consumption. So they're using almost 35,000 kilowatt hours per month, irrespective of the weather. So we immediately say, well, this building might have some issues, maybe lighting, inefficient lighting, interior, exterior, some equipment in there that's running all the time. So I'll give you an idea of maybe what you need to look at in this building. And then we looked at the natural gas consumption of the building. And you can see the opposite trend here, gas consumption high in the wintertime, fairly low consumption in the summertime, and that's a pretty good indicator that natural gas consumption seems to be tracking fairly well, makes sense, it's mostly heating related. The summer months are probably an indication of two things, the hot water heating load in the building and possibly any reheat if it has a type of air conditioning system or HVAC system that uses reheat. there might be. We've seen buildings that use 80% as much gas in the summertime as they do in the wintertime, and we knew there was a big problem with reheating that building. So looking at these graphs gives you an idea, and I'd say heating looks to be fairly normal in this building. And then we take this building and we go to something called Energy Star Target Finder, which is on the Energy Star website as part of EPA. And you can put in information about your building, the square footage, its energy consumption, how many computers are in the building, a few things, and it'll benchmark the building. It'll give you an idea of what a typical building in its type and climate should be using in BTUs per square foot. You can compare that with your building, and it'll also tell you what percentile your building falls in. Are you more efficient than many buildings or less efficient? And it has a list of the types of buildings that are in there on that website. So it's pretty straightforward. So we'd like to take this information and put it in a table that you can look it over and see what's happening with this building. So we make a table. You look at the annual consumption of electricity, annual consumption of natural gas, what the annual costs associated with those were, and we always track what the average unit cost of the energy sources were. The size of the building. So this building, you can see right away, 87% of its energy consumption cost is for for electricity. When we look at how much electricity it uses, kilowatt hours per square foot, we see 32 is the number. That's a fairly intense electrical use. I'd like to see that more down around 20, somewhere in that range for a building like this. Gas intensity use was 0.54 therms per square foot. Actually not too bad. A typical building, an existing building, may be right around 0.5. A new building should be down around 0.3, somewhere in that range. So we add the two together, convert the kilowatt hours to BTUs, and we get 163 kBTU per square foot. Well, the average building in Illinois, probably existing building, uses somewhere between 95 and 100 kBTU per square foot. So this building looks like it's probably about 50% high on its energy use. And its energy cost intensity, the dollars per square foot, it's $3.65. A good building is going to be down around $1.50 to $2 per square foot, assuming it doesn't have a lot of process load in it. So you can see that this building is using more energy than we figured it should, especially for a bank or an office type building. So we put it in this Energy Star Target Finder, and it ranked this bank in a 31 percentile. That means 70% of the buildings use less energy of the same type and weather zone than this building does. Okay. The average for a 50 percentile building in this type would be 104 kBTU per square foot, and we're using 163. And if you wanted to be Energy Star certified, you would need to get that down to 70. So the 70 could become your target for this building. Although this building seems to be a fairly large user, and we probably, I don't know if we could reduce its consumption from 163 to 82. That's about a 50% reduction. That's a pretty good target. I'd say certainly we could probably reduce it in the 30% range fairly readily. So that gives you an idea of where this building stands. There's going to be some opportunity in it. So we need to do the walkthrough. And the walkthrough is you go through the building, take a brief walkthrough, get familiar with its construction type, what's going on in there, what the equipment is, discuss O&M of the building, and then meet with the staff, learn about any special problems or planned improvements in the building, any issues that they're having, and then you can also ask whether or not they've had space changes in the building or what's going on in there, if any usage changes. And then you need to identify your low-cost, no-cost options and estimate that potential for savings in that building by the results of your walkthroughs and your surveys. Now, we recommend that you use a checklist or forms when you go through a building. It just makes it easier. You don't tend not to forget things that way. And there are, on the web, plenty of samples of forms and checklists that are out there. Washington State University has an energy audit checklist that you can find. They have an energy audit workbook. Rocky Mountain Institute has sample forms, and I'll show you later too, ASHRAE has forms that you can download free. So there's some URLs for where to get forms and lists when you go through the building. That way you know that you're going to check everything. You're going to have the data in a comprehensive format, so when you sit down to analyze it, you've got the information that you need.
Okay, and another tool that includes checklists as well is called the PEM Tool. It's the Practical Energy Management Tool, and it helps you conduct energy audits. And it consists of a template of spreadsheets and forms to use to develop and administer an energy management program. A couple things about the PEM is it uses a continual improvement approach. It is designed to meet ANSI 2005 standard for energy management. And for Ameren, Illinois business customers, the PEM tool is free. So if you would like to contact Act on Energy, we can get you a free copy of the PEM tool and have a representative come to your facility and show you how to use the PEM binder. And we're going to give the contact information for the Act on Energy program later in the presentation. So feel free to contact us for a free copy of the PEM tool. And the sections in the PEM tool include the management plan, facility profile, energy use profile, best practices, project prioritization, project management, key performance indicators, and continual improvement. So once again, please let me know if you're interested, and I will now hand this back over to Don.
Thank you. Can we advance the slide? Okay, thank you. Okay, so you're going to take your walk through, and things to note. You want to note conspicuous malfunction in the building, or less than optional function. So people may complain about being too hot or too cold. In the wintertime, you may see a window open. That's probably an indicator that there's either poor ventilation in that space or it's too hot in that space. I call those windows open in the wintertime fresh air thermostats. So you know you've got a problem in the building. People with extra little space heaters under their desks, things like that. And check around, make sure the windows are tight, not loose, any light coming through cracks, lights on when offices are empty, computers running when offices are empty, all these little things you take a look at when you walk around. And then make a list of the potential energy efficiency improvements that need some further investigation. And we recommend, as soon as you've done your walkthrough, kind of sit down and document that information while it's fresh in your mind. And remember the difference between efficiency improvement and conservation. Conservation means not using energy at opportune times. But the name of the game anymore is we don't want to freeze them in the dark. That was kind of the reputation conservation got in the 1970s. Now we want to do measures that maintain or improve comfort while they reduce energy use. So we're improving efficiency, and maybe there are times of the day where you can not ventilate the building or make sure the lights are off. But when people are there working, they need proper conditions and proper lighting. So you go back. You can float these ideas with colleagues and friends, talk about different things you can do in the building, kind of bounce these ideas off other folks. And we always recommend take 1,000,000 pictures. You can't remember everything. Pictures, and take pictures of equipment. You know, take a picture of the label on the equipment so you know the size of things and its energy consumption, that type of thing. Lighting counts. Lighting is a very opportune ECRM nowadays. So you want to, if you have the drawings, make sure the drawings have reflected what's actually in the building. You need to identify the types of lighting in the building. See if they've already converted from T12s to T8s, you need to note that. Although some buildings may even benefit from a replacement of the T8s if they converted at an earlier time. There's more efficient lightings. We always recommend high output T8s now. So you want to look at the number of fixtures in the building. Note how many, so do you have 2 lamp fixtures, 3 lamp fixtures, and then just count the fixtures is the easy way to do it, not individual lamps. And many times when you make changes, you may be changing the whole fixture out rather than changing tubes and ballast. It all depends on the labor cost associated with it. And if you want to get an idea of what the lamp replacement lamps are, you maybe want to check the maintenance closet, and there may be spare lamps and spare ballast in there, and you can get an idea of the types of lamps that they're using in the building. And watch out for the labeling on that lamp. It can be a bit tricky. Make sure you really know what the wattage of that lamp is. And we always write down the codes, and we go to the web and Google them up and make sure we know what we've got for lamps and ballast in the building. And then you do a count. So you can question people in there about the lighting conditions. If you don't have a light meter, we like to go around with a light meter, measure the lighting levels in offices, that type of thing. A typical office should maybe be for 50-foot candles on a working surface. You can find up to 100 in many places. It's kind of, you could conduct an operation in there. So you need to look at appropriate lighting levels. So you need to make a model of the ballast. You need to know whether or not you've got magnetic ballast. Rather than taking the lamp apart to look at it, you can use something called a flicker checker. And it's just like a little top. There's a picture of it down on the bottom right. And you go in there and you spin that. And if it's all smooth gray circles, that tells you it's an electronic ballast. If it's a magnetic ballast, you're going to have little flickering going on in there. And it's going to be sort of bluish or yellowish and gray flickering going on. That tells you it's a magnetic ballast. So you know that those need to be replaced. And actually, I think right now they're not supposed to produce magnetic ballasts anymore. So you can add up the wattage of all that lighting and come up with what we call the lighting power density. It gives you the watts per square foot of lighting. Typically, you're going to find it somewhere between 0.7 and 2. Code now for most buildings is down around 1 watt per square foot, maybe less. You would like to see it, a brand new, high output, well-designed lighting system is going to be somewhere around 0.6 watts per square foot and maybe 0.4, 0.3, 0.4 watts per square foot in operation, because it's going to have occupancy sensors and that type of thing. Estimating the room sizes, you can use ceiling tiles if they're there. If not, have a measuring tape with you so you know how big the spaces are. And as I say, you can poll the people to find out what the lighting levels are, if they're too high or not. And most people have a fairly good feel for if they're underlit or overlit. So some other things to check for in the building: the temperature settings and whether or not they do setups or setbacks in the building. Air sealing and caulking. Go in the building on a windy day. You can see if you can feel air coming into the building anywhere. So there's an opportunity for caulking and foaming and sealing that building up. And we find, we used to think commercial buildings were fairly tight. Turns out they're probably no better than a lot of residential buildings. A lot of construction has not been that great, so there are opportunities to seal up commercial buildings as well as residential buildings. Ventilation. Ventilation is a human requirement in commercial buildings. If there's nobody there at night, there's no need to ventilate that building, so make sure that ventilation is shut down at night. If not, think about what can be done to shut it down at night. Lighting changeouts are a great opportunity. Think about compact fluorescents or LEDs, lighting diodes, to replace incandescent in the building. And nowadays there's enough types and sizes and colors selection that you can pretty much get rid of all the incandescent in the building. And certainly any T12s, the 1.5-inch fluorescent lamps need to be converted to either T8 or T5s. Difference between T8 and a T5, the T8 you can sort of look at it. The T5 tends to be a fairly bright source, and normally it's used as an indirect lighting fixture. And that's we tend to recommend T8s over T5s, even in high bay applications. Think about tune-ups of the HVAC equipment, boiler tune-ups, furnace tune-ups, making sure the AC unit has the proper refrigerant level in it, because under filling it and overfilling it both reduce its efficiency. It needs to be just right. If the building has steam traps, think about having a steam trap survey of the building. So there's a lot of things in that HVAC system that can be looked at. And you may also consider, can you get where are you buying your electricity from? And ARIES is an alternate retail electric supplier in the state of Illinois that's pretty much available statewide now. As your electric company generally just passes through the cost that they buy the electricity for. So you can buy it on your own or buy it from them, either one. There may be some cost advantages there.
Okay, now I'd like to let you know of a couple other options. Besides conducting a do-it-yourself energy audit, we do have a couple other ways that you can have audits done that are free. One way to conduct a level 1 walkthrough is to contact an energy advisor from the Ameren, Illinois Act on Energy program and request a free walkthrough. These energy advisors will come to your facility to do a walkthrough and let you know what upgrades you can make to save energy and money at your facility. And this map shows the Ameren, Illinois territories covered by each energy advisor, but if you'd like, you can email me or call me, and I can give you the phone number of the energy advisor in your area and let them know that you're interested in an energy audit or a level 1 walkthrough of your facility to see what kind of improvements can be made. Another option for getting an energy audit is to hire a contractor who can conduct an energy audit for you. This one may not necessarily be free, but it is another option if you would rather have someone else do an energy audit for you rather than a do-it-yourself energy audit. So one way to find a contractor to perform an energy audit is to contact a program ally who is a partner of the Ameren, Illinois Act on Energy program. And these program allies have been trained in how the program works and have experience in conducting projects with the Act on Energy program. And so you can find a list of program allies on the Act on Energy website. If you can see where to find that here on this screen. And we don't know which of these allies would conduct energy audits or what they might charge for an audit, but it is another option if you would like a professional audit. Okay, now I have another question for you. If you could please submit your responses. I'd like to know, have you performed an energy audit in the past? Have you ever done one of these at your facility before? Okay, the responses are coming in pretty quickly, and just about everybody has responded, so I'm going to go ahead and close down the poll, and I will share the results. It looks like the majority of you have not performed one in the past, so it's a great opportunity to identify energy-saving opportunities at your facility. Thank you very much for your responses. Now I'm going to turn this back over to Don to continue to talk about level 1.
Okay, so you've done the walkthrough. You've got some ideas of how you can save energy in a building. You probably need to document this process. So what we recommend is you develop what we call a level 1 report. You quantify the savings from rate changes if that's a possibility. You discuss results of utility bill analysis and the benchmarking. You know, make the tables that I showed, and there are actually templates to do that available. I'll show you the resources for those at the end. Discuss any problems or special needs you identified, any needed O&M changes, and then list the cost reduction measures and the estimated savings. And then any potential capital improvement that you saw on the way through. Does maybe a RTU needs to be replaced or something like that. It's a more higher priced item than just going through and you know, checking thermostats and changing lighting out. So that's you know, document these things, present them in an effective manner that's so you can sell this to the owner of the building. So next step is what we call a level 2 survey. You want to review the mechanical and electrical system design, the installed condition, any maintenance practices, any operating methods. This is a fairly thorough discussion of the building operators. Review any problems that they've come up with, and they'll tell you if there are issues in the building, and then recommend improvements to these systems. and then describe and analyze any energy using system in the building based on your observations, measurements, calculations, and the measurements you've done on hand. So level 2 is a little more in depth. You may need to do some measuring, some metering, that type of thing in that process. But following items that you probably should look at in this level 2, look at the building envelope. So ascertain what the insulation levels are. Can there be improvement in the insulation levels, and can they be installed fairly reasonably? Look at the plug loads in the building. By that we mean anything that's plugged into a wall outlet is a plug load. So is there a coffee pot on every desk? Is there space heaters under the desk? All these kinds of things add to the plug loads. Certainly computers, copiers, these things, make sure that they're using the sleep features of these equipment, so when they're not in the office, they'll go to sleep and go to a lower energy mode. The lighting, the HVAC, if there's any process like laundry or food prep in there, refrigeration, any conveying system, all those process loads need to be looked at and make some recommendations. Then there's also some people have pools and saunas and spas. There's plenty of opportunity in those types of buildings too. And CDAC, on our website, we have what we call energy fact sheets, and we talk about what you can do in different types of buildings. So we have a whole set of these, and we do have one for pools and spas and that type of thing where you can save energy. Domestic hot water, what's the temperature of the water? You probably want to, in many cases you can turn that temperature down. You can also turn water heaters off at night when they're not being used, especially if there's a circulating hot water pump. You may want to put that on a time clock. Then you can prepare a breakout of the annual energy uses. Estimated these equipment that's in the building, how much it would be using in a typical year, give a feel for where the energy is going in the building. And there are forms available to assemble this data. So, estimating the energy breakouts. The following is kind of the way to go about that, and I'm going to go from the best, the most accurate to the least accurate. So detailed measurements over time, actually putting in some metering in the building to measure equipment. Spot measurings with estimates of run times on an annual basis is another way. And then sit down and just do a detailed hourly calculation with a simulation program. You can put the details of the building in there, and it'll give you an idea of where the energy is going in that building. And what we do is we calibrate the model, meaning that we get the energy bills of the building, and then we put a simulation of the building up, and then we adjust the simulation to the point where it sort of matches the bills based on the weather that the building saw, and then we call that a calibrated model, and that gives you a fairly good idea of where the energy is going. And then you can make assumptions of typical end use densities. CBEX is here. CBEX stands for Commercial Building Energy Consumption Survey. It's available at the DOE website. Just Google CBEX, and they have what they call the energy book, and in there is all kinds of information on commercial buildings and what percent use, where the energy goes, and these type of things. So it's a good idea to look at that to get a feel for how buildings use energy. And as I mentioned, the accuracy decreases as you go down the list. Here's that energy uses breakout in that bank. This is by energy. As you can see, the largest energy consumer was heating. Okay, then domestic water, exterior lighting. There was a server room in there, miscellaneous loads, fans, lighting, cooling. So the three big ones are what? Lighting, cooling, and heating. So that's the energy use breakout, but how does the cost breakout look? When we break it out by cost, the picture changes a bit. You see that heating drops from, it was 32% down to 14% of the actual cost of operating that building. So it tells you that the electrical things in that building are probably going to need the most attention. Certainly lighting and cooling, some of the miscellaneous loads, maybe there's something we can do in the server room, and certainly exterior lighting, we could take a look at that. So when we surveyed that building, we did an analysis, and this is what we came up with we could do in it. Remember that building was fairly energy intensive on the electrical side. And what we found is that you could just reducing, putting better lighting in, lighting controls, putting some lighting controls in. The annual savings for those two alone were probably almost 55,000 kilowatt hours. Thermostat replacements, we found the building had real control problems with the thermostat, and we recommended replacing all the thermostats in the building. There was one in every room. That's why it's a little costly ECRM there, about $4,600. But 13% energy savings based on that. Testing and balancing, demand ventilation, demand control ventilation. That means you control the ventilation based on the population in the building. It's generally done by measuring CO2 levels in the building, and you automatically adjust the ventilation based on population of the building. It's a very efficient way to go for ventilation nowadays. Variable frequency drives on the air handling unit to save there. Computer power management, about 14,000 kilowatt savings available there. And you notice that when we look at the kilowatt hour savings, and some of them have a therm savings associated, and some have a negative therm savings. So when you change lighting out, lighting is doing some of the heating load of the building, so you're gonna have to heat a little bit more from natural gas. So those are negative numbers. But all in all, we found pretty much 117,000 kilowatt hour savings, which is about 23% of the electricity in that building, and we found about 3,300 therms, which was 38% of the heating energy. So overall, we could reduce the building consumption by 29% and its energy cost by 26%. So, and that's not untypical of what we find in buildings. Somewhere in that range, 25 to 30% savings is very typical for an existing commercial building. And then when we look at the cost associated with this, there are incentives available for certain of these items, so we take into account the incentives that are available. It makes your economics better, and you can look at the utility website and it'll give you an idea of what the incentives are. You can also work with their representatives. And also, there are now gas incentives available too, and there weren't last year when we did this report. So the capital cost would be even less this year because there's more incentives available. So initial investment is maybe $40,000 in that building. It has a 37% internal rate of return. That means if I took that money and invested in that building, I would get a 37% equivalent interest rate on my money. And you got to say to yourself, where else today am I going to get 37% of my money? You put it in a bank and you're maybe going to get 0.5%. You put it in the stock market, there's no telling which way it's going to go nowadays. So investing in energy efficiency in this building is probably a very good use of capital. And it has a net present value. We look at over the life of the equipment and say it's going to save $64,000 in addition to paying for itself. So it makes sense economically to look at improving these buildings. So some of the things we see when we look at a lot of buildings, efficient lighting is the number one thing we look at. Then we look at the weatherization and sealing of the building. We look at a large building, probably commissioning or retro-commissioning or recommissioning of the building, HVAC. We're finding anywhere from 15 to 30 or 40% energy savings in newer buildings. These are buildings that are 5, 6 years old that have a building automation system that is not operating properly. Great energy savings from them. Temperature setups and setbacks. Efficient boilers and furnaces. If you're replacing any equipment, any rooftop units or anything like that, buy the most efficient one available. There are incentives available now to buy down that extra cost for the high efficiency units. High efficiency cooling systems, same thing. Ventilation adjustments. If at the very least schedule the ventilation in the building, with a time clock or something, or do demand control ventilation. Very great savings associated with ventilation. Is quite expensive, and it's only needed for when people are in the building. Electric motor controls, VFDs, variable frequency drives, insulation upgrades, and window upgrades. We put window upgrades last. They tend to be pretty expensive. You're talking $40 to $50 per square foot of window, and it's a tough payback on windows. They're typically out about 20 years. So we kind of look at them last. But if you're going to replace windows anyway in a building, certainly put an excellent window in. You want windows with probably a U value now down to 0.25, which is an R4 window, and and code requires that they be low emissivity, low E windows nowadays. So lots of different things to look at. There's plenty of opportunity. These forms and spreadsheets are available from the ASHRAE website, the ASHRAE.org. PCBEA stands for Procedures for Commercial Building Energy Audits. So, and then all these forms, the template to PEA is the annual performance table, shows you how how you evaluate and rank the building. And then there's all kinds of other things, and sample forms, and use breakdown forms, summary tables to present your information, hourly simulation checklist. So a lot of information is out there, free on the web. You can just download it, and it gives you some guidance on how to do this audit. Other tools and resources, there's a self-audit tool on the web called energyguide.com. It's a good thing to, if you're even thinking about doing an audit of a building, put your building, some basic building information in there. It gives you an idea of the breakout of the energy use in that type of building and some other information, and gives you an idea of what to look at. We have a very extensive website, and I say we have fact sheets on different types of buildings and how to look at those buildings. The Energy Education Council has what they call an energy efficiency resource. They have a great deal of information that they've compiled on energy and energy auditing. And then, of course, Energy Star Commercial Building Resources, and they have good information on energy management and that type of thing. And you notice that the PEM process sort of follows the Energy Star management guidance. So that you're going to see things that sort of tie together with different guidance out there. So this is our website, how to contact us. You can email us at info@cdac.org. That comes to me and several other people. And we have an 800 number that you can call if you have any questions on energy-related things or energy auditing, anything like that. As I said, we've done actually now over 900 buildings. We're, I think, 928 we're at right now, energy assistance to buildings in the last several years. So we have a staff of engineers and architects who are fairly knowledgeable in this stuff, so you can just give us a call or search our website for information about auditing. And our services are free. They're funded by the Illinois Energy Office from the Portfolio Standard programs.
Great. Thank you very much, Don. Very interesting and very helpful information on how to conduct energy audits. I want to remind everybody that you will receive a link to a copy of this handout from this presentation, so you'll get a copy of all the slides. That way, if you want any of this contact information or any of these websites that Don mentioned, you will be able to get those from the handout. Also, here's the contact information for the Act on Energy program. If you'd like this information, please feel free to visit our website for more information about the energy advisors, and this information will be included in the handout as well. Now it's time to do the final quiz. So I'm going to pull this up, and once again, these will be the same questions that you answered before, and we'll see how much you learned. Okay, I'm going to open the poll now, and you'll have about 60 seconds to submit your responses. Okay, it looks like most of you have submitted your answers, so I'm going to give you just a few seconds here to finish up for the rest of you. And I'm going to close the poll down in 3, 2, 1. And I'm going to close the poll, and I'll share the results to let you know what everyone responded, and also go over the correct answers for each question at this time. So for number 1, the question is, what does ECRM stand for? It stands for Energy Cost Reduction Measure. Number 2, to check light counts and levels, you should do which of the following? The correct answer is C. Use a flicker checker to identify whether a ballast is magnetic or electronic without disassembling the fixtures. And number 3, what are the 2 types of buildings? The correct answer is B, envelope dominated and internal gain dominated. So great. Everyone did a great job. Thank you very much for your responses. And next, I'm going to ask you if you have any final questions. So if anybody has any questions, please type those into chat, and we will get those answered for you. So any questions that you still have remaining, please let us know. While I'm waiting for your questions to come in, I'd like to let you know about an upcoming training event. Act on Energy is hosting Certified Energy Manager training. It will take place from March 26th through March 30th. And we're hosting this along with the Association of Energy Engineers, and it's going to take place at the Ameren, Illinois building in Peoria. The cost is $16.95, and please see the Act on Energy website for more information and to register for this event. Then we also have a couple of other webinars coming up pretty quickly in February. We have Implementing Energy Efficient HVAC Controls. That's Energy Efficient HVAC Controls with Reinhard Seidel, and that's going to be at 12 o'clock noon on February 8th. And then we're going to have a retuning or retro-commissioning webinar with Srinivas Katapamala on February 22nd at noon as well. So you can register for these on the Act on Energy website on the Education and Training page. So I'm checking to see if anyone has any final questions. I don't see any questions. Oh, here we have one that just came in. What suggestions do you have about a manufacturing or grain elevator setting that's mostly outside and dealing with large HP motors?
Okay, for large horsepower motors, first, the efficiency of the motor may be of concern, but the larger ones tend to be more efficient than smaller motors. You may look at possibly variable speed drives for the application depending on how the motor is being used. Also, if you're doing grain drying, there's opportunities there because newer grain drying equipment is more efficient also.
Great. Thank you very much. And then here I have another question. It says we have both multifamily and office type building uses. How similar would an audit be of these building types? Are there any pointers you could recommend regarding a multifamily audit?
Well, the multifamily audit depends if you have central systems or not. If you have centralized heating or centralized cooling, then basically it's anything over 3 stories is considered a commercial building anyway. So some of the same techniques would apply. We look at a lot of high-rise buildings. And then
Okay, sounds like we have lost Don on the audio, so maybe he will come back. Don, are you back? Okay. do we have any of our technical reviewers on the line or energy advisor who might be able to answer this question about buildings? Or
this is Andy Vaughn. The only other thing I might say about the multifamily, I didn't catch all that Don said, but you might need to look at the metering scenario and whether it makes sense to look into the individual residential units on your own or not. We also had another question about real-time energy monitoring systems and lead points. I'm not familiar enough with the lead point system to make any comments about that. Maybe that's something you could email us later on, and we'll find someone if you have questions about that could answer it.
Great, thanks, Andy. Yeah, please feel free to email me, and I'll or the Act on Energy program, and we will definitely get that answer for you. So here's the Act on Energy email if you would like to mail that back in. So thank you all very much for joining us. Looks like we are out of time, and thank you very much, Don, for telling us about energy audits. It was very interesting. And it looks like this concludes today's webinar since we don't have any more questions. So thank you very much for joining us, and have a great day.